This is the third video of looking at example 1. So here's the scenario we have. In the second video, or rather the first video, we looked at how do we actually establish the linear program. And in the second video, we began graphing it out. So we graphed out the constraints. What we haven't incorporated yet is the information we know about the profit function. So the profit function is this. We're going to rewrite this profit function solving for x2 so we can put it on our graph. So our profit function is x2 is equal to, we'll do this 300 x2, is equal to profits minus 350 x1. So x2 is equal to profits divided by 300 minus 76 x1. Now we want to be able to graph this out, but one thing you'll notice is how do we graph it out if we don't know what profits are? We know what the slope is. The slope is negative 7.6, but we don't actually know the profits. So when we do this, what we're going to do is let's insert a number in for profits. So let's just assume that we want to make profits of 30,000. Well, if that's the case, that's going to be the point 100. That's going to be our y-intercept. And our slope will be negative 7.6. So for every 6 we go over, we're going to go down 7. So now, as we change our profits, as we put our profits not at 30,000, but say let's put them at 33,000, well, now we divide that by 300. It's just going to take our profit function, our line, and just shift it up. It's not going to affect the slope at all. It'll still be a parallel line. And so there we have another line where our profits are even greater. So let's keep shifting this. See if we can actually make these look somewhat parallel. There's another one. And there we have our first extreme value. We've reached that corner. So at this level of profit, it's feasible for us to achieve this. But the question is if our profits are increasing as we keep going higher, we can increase our profits just a little bit more, still be within the feasible range, yet have higher profits. So we're not going to stop here. We're going to continue increasing our profits until we keep going higher. So what you'll see is our profits keep going higher. We'll end up hitting this point, and then we'll end up hitting this point. And lastly, once we hit this point here, our profits can go no higher. So the extreme point theorem says we have one of 4 possible solutions. Based on our profit function, this negative 7.6, this here is our answer. Well, how do we find that answer? Well, this point is where the blue constraint equals the purple constraint, because it's where the blue line equals the purple line. So to solve for that, we'll set 200 minus x1 is equal to 261 minus 3/2 x1. Okay, so we add a 3/2, we get 1/2 x1 is equal to 61. x1 is equal to 122. That's our optimal x1. Now to find our x2, we just plug this back in to this equation, for example. So x2 is equal to 200 minus 122, which is about 78. And so that there, 122 and 78 are our optimal solution for this linear program. And therefore we've now found the solution. Now what we're going to do next in the fourth part is we're going to look at a computer program that does this for us to see if we get the right answer.